pavement shoulder improvement. So basically, this is a combination of few of my research work and some of the literatures on pavement shoulder and pavement performance. Next, this is the presentation outline, which covers a brief introduction on pavement performance, then evaluation of pavement performance, how to measure pavement performance, then a study on pavement shoulder and its failures. There are different kind of pavement shoulder failures. We will discuss on it. Then a brief overview on ANN, that is artificial neural network, which is used in some of the analysis. Then some laboratory experiments, falling weight deflectometer test is there, and wheel tracking test is there, and the resultant discussion found from these laboratory tests and the conclusion. Now, as we all know that it's very pleasure to say that India is the second largest country in the world in road network. The total road network in India is around 6.2 million kilometers, and that of in Tripura, the total road network is around above 16,000 kilometers. And if we see the scenario in the rural area, the total road network is around 3.5 million kilometers in India. And in Tripura, the total road network in rural area is above 10,000 kilometers. But it is very undesirable that the condition of maximum roads in rural area are very miserable. Different types of failures are occurring. There are different literatures on pavement, the improvement of pavement performance. Different new technologies are introducing to enhance stability, improve the of poor pavement performance. Every year, a huge budget is being invested on the maintenance work of pavement. You can see here, last year the total budget was around 120 crore in Tripura only for the maintenance work. So this is very unfortunate. Now, what is pavement performance? Condition of road. It includes different types of failures, then riding comfortability of passengers, then serviceability, the overall life of the pavement, then the condition of the pavement, etc., etc. We can see there are different types of pavement failures occurring on a pavement, like potholes, that means the bowl-shaped depression in the pavement section, then rutting, that is the vertical deformation along the pavement surface, then surface delamination, that is the total bituminous surface is removed in some areas. All these are come under pavement performance. So how to measure, how to evaluate pavement performance? There are basically two methods. One is to measure roughness index. Another one is to measure the pavement condition index. To measure roughness index, basically we can use different types of instruments. You can see here there are different instruments like a bump integrator, then surface profilometer, then Marlin axis profilometer, etc. For first one, bump integrator, this is one heavy instrument The instrument is mounted with one motorized vehicle, and the vehicle is moved along the road surface over which on which the roughness index is required to measured. Okay, the instrument is moved along the road surface, and the after completion of the total stress, the total undulation of the road profile is measured in the digitally through a software. Okay, in this case, the vehicle is required to operate at the speed of 32 kilometer per hour only. For the second one, surface profilometer, there is also one instrument which is mounted with which is required to mounted with the vehicle, motorized vehicle, and the vehicle is moved along the road section, and the total undulation, the total amount of deformation is calculated digitally through one software. Then Marlin, it is a hand operated instrument. The instrument is manually moved over the road section. There is a wheel which is moved, and after one revolution of the wheel, the total record is measured graphically. Then axis profilometer, this is also operated manually, and one software is connected with the profilometer, through which the surface profile is measured graphically, as well as the total deformation or the total undulation is collected. So these are the few of the instrument which we can use to measure the roughness index. Basically, the roughness index is measured in terms of international roughness index. In different instrument, different values we can found like roughness index value, unevenness index value, bump indicator value. But the international roughness index is the standard value to determine the roughness index. So we have to convert that value to the international roughness index value, which is globally standardized. Now, test bump integrator instrument. Basically, the bump integrator instrument is required to operate at the speed of 32 km per hour. But practically, this is very difficult to maintain a constant speed in a road that is 32 km per hour, because there are heterogeneous traffic in rural areas, especially. There are different types of pavement failures, kettles are there, then pedestrian traffics are there. So because of that, it is almost not possible to maintain that constant speed of 32 km per hour. That's why one test is there to calibrate bump integrator instrument, so that we can operate the instrument at any speed and convert the value, that means the roughness value, at the standard speed of 32 km per hour. So the instrument is operated at this 7 speed, that means at the speed of 20, 25, 30, 35, 40, 45, and 50. Okay. So total 10 stretches are road stretches are taken, and the unevenness index value is calculated for all the speeds, as well as the instrument is operated at the speed of 32 km per hour, and the unevenness index value is calculated. And based on this data, some equations are derived using regression analysis to convert the bump indicator value, that means the unevenness index value, from this constant speed, that means 20, 25, 30, 35, 40, 45, and 50, to the standard speed of 32 km per hour, because the standard roughness index value gives at the speed of 32 km per hour only. Now, one generalized equation is also derived using multiple linear regression analysis so that we can operate the bump indicator instrument at any speed and calculate the standard value of unevenness index at the speed of 32 km per hour. So this is one calibration test. Next is distress measurement. That is the another method to evaluate pavement performance. Here we can evaluate pavement condition index. There are different types of pavement failure occurring on a pavement surface, like pothole rotting, cracking, shoulder drop, etc., etc. I have highlighted here only these four types of distresses, because these four types of distresses are found basically in the road of Tripura in a new constructed road. Okay. So survey it means elevation. Then second one is edge breaking. It is observed that in many of the road stretches, the edge portion of the road is damaged earlier. Okay, this type of failure is called edge breaking. Then rutting. This is the longitudinal, this is the vertical deformation in the path of wheel movement. This is a structural failure which occurs due to uneven settlement of subgrade, inappropriate compaction, etc., etc. Then surface cracking. It includes different types of cracking, like alligator cracking, then longitudinal cracking, block cracking, transverse cracking, etc. So this type of cracking generally occurs due to improper gradation, then insufficient materials, etc. So basically these four types of failures are found in the rural roads in Tripura in the initial period. And some data is collected, periodical data is collected for a year in some roads. And this data is plotted graphically. It is observed that for these two types of failure, that means surface cracking and rutting, these two types of failures are very minimum at the initial period of data collection. The roads which are chosen, all the roads are completed in 2012, and data is collected in 2013 from January to December at a regular interval of 3 months. And it is observed that at initial period, these two types of failures are less, but it suddenly increases at the end time. That means at the time of September and December, you can see the failure amount is very high. But if you see the data of shoulder drop and edge braking, it is observed that the value of shoulder drop and edge braking is very high from the initial time of the road. Okay. So from this data and from this survey, it can be said that this shoulder drop and edge braking is the first failure that is occurring on a road. After that, another type of failure, that means the surface cracking and rutting failures are occurring, and other types of failures are occurring, and pavement deterioration are occurring. So shoulder drop and edge braking are the first two failure which is occurring in a new constructed road. And the survey is conducted in the rural roads in Tripura, in different districts. Now, what is the cause of shoulder drop and edge braking? Basically, in which is constructed with 4 layers: subgrid, subbase, base course, and surface course. When load is applied, traffic wheel load is applied at the edge portion of the pavement section, one lateral pressure is exerted in the shoulder section, and in maximum road, the shoulder section is untreated. That means the earth shoulder is provided in the rural. So if the shoulder is untreated, it cannot resist this lateral impact of the wheel force. Again, it is often observed that the wheel is moving along the section which is untreated, compacted. Case in that case, the material of the shoulder section get deformed and settled, and thus this portion, corner portion, get supportless, and it in this way the shoulder drop is occurring. That means the shoulder drop failure is occurring. Now, if we can replace this untreated shoulder using by a lateral force, lateral impact of wheel load, and the total deformation can be reduced. Now take a look on the pavement shoulder section. What is pavement shoulder? So pavement shoulder basically is the extra passage provided along the pavement surface adjacent the pavement surface. So it serves different purposes, like it acts as an emergency lane. Then in some areas, especially in the other district roads, it acts as a temporary parking plot also sometimes. Then in rural area, it acts as pedestrian passage. Then structurally, it provides lateral support to the pavement section. So this is very important to maintain the pavement shoulder, because it is serving different purposes, and structurally also it have a high impact on the pavement performance. Now, what are the shoulder failures? There are different kinds of shoulder failures occur on the pavement shoulder section, like surface depression. First one is surface depression. This is the vertical deformation occurring on the shoulder section. This type of failure can occur due to application of heavy traffic load in an uncompacted or untreated shoulder, then inadequate compaction of the shoulder section. Generally, we can see during construction of a road or maintenance of a road, the pavement section, that means the blacktop portion, is specially focused and compacted perfectly, but the shoulder section is often neglected, but it has a high impact on the overall performance of a road. So this shoulder section is also need to be compacted. So this type of failure can accumulate rainwater, and further this rainwater can percolate through the layers of the pavement, and the total pavement section can structurally damaged. Next is bush covered area. In many road section, especially in the rural area, it is observed that the shoulder section, that means the earthen shoulder section, is totally covered with small plants and bushes. It is required to maintain properly. This type of failure occurs due to improper maintenance work only. So the root zone of these plants can enter the pavement layers, that means the pavement structures, and small cracks can be occurred. Okay, so this is also one type of failure in a shoulder section, which affects the overall performance of a road. Next is shoulder drop. As I have said earlier, the shoulder drop is the elevation difference between pavement surface and shoulder surface. So it is also called as shoulder failure, and it occurs due to inadequate compaction and heavy application of heavy traffic load in the earthen shoulder section. It further creates different types of pavement failure like edge breaking. Then it also causes severe road accidents also. So next is shoulder rutting. Rutting is one failure that occurs in the pavement surface as well as in the shoulder surface also. And the cause is almost same, application of heavy traffic load, due to which the vertical deformation occurs in the shoulder section. Next is insufficient width of shoulder. As per IRC, the width of the shoulder should be around 1.8 meter, but in maximum roads, especially in the rural area, the sufficient width of the shoulder is not maintained. So this is one type of failure, because shoulder section provides lateral stability, and so if the shoulders width of the shoulder is not sufficient, it will not provide the sufficient lateral sufficient amount of stability in the road pavement section. So next is improper cross slope. The cross slope in the shoulder section will be almost same as the pavement section. Same as the pavement section. But in many road, it is observed that the proper cross slope is not maintained. Again, in some roads, the cross slope is formed in the opposite direction. That means towards the pavement section. And this is formed due to the formation of surface depression, rutting, etc. In that case, it can accumulate rainwater and the total structure of the pavement can be damaged. So this is a severe type of failure, shoulder failure. Now, what are the IRC recommendation for shoulder section? Basically, IRC recommends only the width and the cross slope of shoulder section. As per IRC, the width will be 1/2 the difference between roadway width and carriageway width. That means the roadway width is 7.5 meter and the carriageway is 3.75 meter for rural roads considering single lane. So the total width of the shoulder section is almost 1.8 meter, and the cross slope will be same as pavement section for paved shoulder, and it will be 0.5% more in case of an earthen shoulder. So it is very essential to maintain the shoulder section as it serves as it has a high impact on the overall pavement performance. Now, this is one procedure to maintain, to evaluate the condition of shoulder, that is the shoulder condition index. Basically, to determine the condition of a pavement, usually we use pavement condition index. That is a prioritization rating system. Basically, it is maintained for the pavement section only, based on different types of pavement failures. As shoulder section also has a high impact on overall performance, it is also required to maintain, also required to measure the shoulder condition also. Okay. So prioritization index can be determined in some rating from 1 to 10 or 1 to 5. Here, this is one result of one investigation where the shoulder condition index is given at the rate at 1 to 10 rating, and these are the visual observation based on which the shoulder condition index is given from 1 to 10. From for rating scale 10, that means the excellent scale, there will be no visible deficiencies and it will be properly leveled and well maintained. For rating scale 9, there may be some slight discrepancies and the leveling should be proper and well maintained, and so on. The road sections can be scaled from 1 to 10. Now, this scaling or shoulder condition index can be evaluated or analyzed using artificial neural network also. Here is the one application of artificial neural network. So first of all, let's have a discussion on what is artificial neural network. Basically, the concept of artificial neural network comes from our biological neural system. In the biological neural system, there are three parts in one neuron. That is dendron, the neuron or neural cell or nucleus, and the axon. Dendron collects information from the adjacent cells and transfers to the central neuron section. And the neuron processes that information and passes to the axon. And the function of axon is to collect the information, processed information from neuron and transfer to the adjacent neural cell. Same concept is applied on the artificial neural network. Here also there are three layer. One is input layer, then neuron or node, central node, and output layer. Okay. The input layer is the input parameters. That means the known values of an equation. Then the central node evaluates the information or processes through some mathematical algorithms and gives one decision, that is the result. And we got it through the output layer. So basically, this is the function of artificial neural network. So there are different softwares on artificial neural network. In artificial neural network, yes, there are three layers: input layer, central node, and output layer. In input layer, there are different types of mathematical tools. There are different softwares. In each software, there are one or multiple numbers of mathematical tools that is customized in the software. So based on our problem statement, we have to choose that software. Like there are different software like JustNN, EasyNN, Eluda forecaster is there. Then fuzzy weight NN, that is based on the fuzzy logic system. Then MATLAB. In MATLAB software also there is a toolbox of artificial neural network. Then DarkNet, Neuro, then Neural Designer, etc. Many more softwares are available in the market. So based on our problem statement, we have to choose the software. We have to select the software, select the mathematical tool, and based on this, artificial neural network is conducted. So here is one analysis, one example of artificial neural network through which the shoulder condition index is evaluated. Here, the input parameters, that means different types of shoulder failures, 6 types of shoulder failures are chosen, and it is inserted as input parameter. And the output parameter, that is the shoulder condition index value, is evaluated. In this case, EasyNN software is used. And training algorithm is quick propagation. This is one trial and error based analysis. In this software, there are 3 to 4 mathematical algorithms are customized: quick propagation, back propagation, feed forward, etc., etc. And by conducting trial and error method, this best fitted network is developed. So using this network, it is possible to calculate shoulder condition index based on this particular types of failures. So parallelly, in this software, another analysis is performed, that is sensitivity analysis. According to this analysis, the impact of each shoulder failure is calculated. So it is observed that the age drop or shoulder drop has the highest impact on shoulder condition index compared to the other failures. Again, one equation is derived using regression analysis to calculate shoulder condition index based on these 6 types of shoulder failures. This data is based on one survey in the rural roads in Tripura. Basically, these 6 types of shoulder failures are found and collecting data of these 6 types of failure, the shoulder condition index is calculated. So this is the comparational chart of AN and predicted shoulder condition index, regression analysis, predicted shoulder condition index, and the actual value of shoulder condition index that is performed by the visualization. Okay. Now, this is one treatment of shoulder section. It is very essential to modify the shoulder section, Arden shoulder section, and make a stable shoulder section. Here, coir fiber, coconut coir fiber is used to modify or treat the Arden shoulder. Coconut coir fiber is mixed with the subgrade soil of the shoulder section and stabilized properly, compacted. The fibers are coated with tar to increase the durability. Here, these are the physical properties of the fiber. Basically, the tensile strength of the fiber depends on the maturity of the tree. Here, the tensile strength is 15.3 kilonewton per meter square. The water absorption is 61%. Length are 0.5 and the which the fibers are mixed with. So these are the engineering properties of the sample, both the untreated sample and the treated sample with coir fiber. Here we can see the maximum dry density can be decreased from 8.1 to 12.24. Then optimum moisture content 12.9 to 16.9. Then soaked severe can be increased from 4.5 to 7.35. Unsoaked severe is 8.25 for untreated sample and 11.92 for coir fiber treated sample. Then unconfined compressive strength is 630 kilopascal for untreated sample, and that is 695 kilopascal for the coir fiber treated sample. Next, there are some laboratory experiments. Conducted to evaluate the vertical deformation in the shoulder section, both for the treated and untreated samples. So basically, wheel tracking test is conducted to determine the rod deformation. Here, there is a wheel in the instrument which is moved over the sample. The sample is prepared like this. The picture is shown here. First of all, two circular samples are prepared and one portion is cutted from each of the samples and the remaining portion is attached, and the wheel is moved at the center portion of the sample. So after certain number of revolution of the wheel, the total deformation is measured. That is considered as the rod deformation in the sample. So data is collected, the test is conducted, and the data is collected for both the treated sample and untreated sample. It is observed that the rate of deformation is around 0.46 for untreated sample, and 0.32 for the coir fiber treated sample. And the deformation can be reduced by 29.06% after treating the sample using coir fiber. And the stability is 180.96 cycle per mm, and that is 255.110 cycle per mm for coir fiber treated sample. So the stability can be enhanced by 40.97% after treating the sample with coir fiber. Here is the graphical representation of the data. That means the vertical deformation we can see here. So next, another test is conducted, that is falling weight deflectometer test. Basically, this test is also conducted to determine the vertical deformation in a road profile. There are some geophone sensors are mounted with one beam that is connected with the instrument, and through these geophone sensors, the vertical deformations are measured at different points. So there are 7 geophone sensors. The first geophone sensor is placed below the axle of the wheel. Then other geophone sensors are placed at a regular interval of 0.3 meter. Now, for this test, the instrument is placed in such a way that the instrument is placed in the pavement section. Here you can see one test pit is constructed with by mounting pavement section and shoulder section. Okay, the shoulder section is the earthen shoulder. It is the material of the shoulder section is changed in 2 cases. In first case, there was untreated shoulder, that means only the soil, and in second case, coir fiber was mixed with the soil sample. So next, an impact load of 40 kilonewton is applied by the instrument, and the total deflection at each geophone station is measured. And the height of fall is 300 mm, 400 mm, 500 mm, and 600 mm. For 4 types of measurements. So this is the data or graph for 300 mm fall. It is observed that for fast geophone sensor station, that means S1's point, the vertical deformation is very less. And for the other geophone station, the vertical deformation is little high, because the fast geophone sensor is placed in the pavement section that is made of bituminous surface, and the other geophone sensors are placed in the shoulder section, that means the earthen portion. That's why the vertical deformation is very less in the pavement section, that means the first geophone sensor, and it is high in the remaining geophone sensor station. And it is also observed that the vertical deformation can be decreased by using coir fiber with the soil, subgrid soil. So for other conditions also similar type of graph is observed. And this is the data. it is observed that the total vertical deformation can be reduced by 34.54% when the load is applied from 300 mm height. Then it is 29 maximum value of maximum 29.76% when the height of fall is 400 mm. Then vertical deflection can be reduced by maximum 25.80% when the height of fall is 500 mm, and for the last case it is 36.02% maximum value, which can be reduced for 600 mm height of fall. So basically the vertical deformation can be reduced by 25.8 to 36% if we can treat the shoulder materials using coir fiber. So this is the thing. Now these are some concluding remarks. Here the major shoulder failures are observed as surface depression, bush covered area, shoulder drop, insufficient width, routing, etc. Then the shoulder section is modified using coconut coir fiber coated with tar to increase the durability. Then ANN, artificial neural network, can be used to determine shoulder condition index, which is very essential to calculate to evaluate the performance of a road. Then falling weight deflectometer test. Using this test, it is observed that the vertical deformation in the shoulder section can be reduced by 34.54%, 29.76%, 25.80%, and 36.02% for the impact load from 300 mm, 400 mm, 500 mm, and 600 mm height of fall. So these are the concluding remarks, some references, and that's all.
Thank you very much, madam. It was such a wonderful presentation. I hope all the participants has got some valuable inputs from your presentation. And we expect that in near future also, whenever it is required, we will get the help from your side for conducting such kind of wonderful sessions. Thank you, madam. Thank you very much.
Thank you. Thank you.
And now I am asking all the participants if there is any doubts or any queries about this presentation or anything you want to share with our respected madam, you can share. It's open to all the participants. If you have any kind of queries, any kind of doubts, you can share with our expertise. So I think there is no queries from the participant side. So we can end this particular session with this note.
Okay.
And to all the participants, there is an announcement that we are going to join for the day 4 of this particular FDP. And tomorrow will be a technical lecture by Dr. Bornali Devnath on the pavement design and construction. We will be joining at sharp 6:20 p.m. and the session will be start on sharp 6:30. So with this note, I am ending this particular session. Thank you for joining. Hope to see you again tomorrow. Good night.